All right, so this week we're going to be talking about graphing linear equations using the x and y intercepts and using the slope intercept form given the slope and the y intercept. We're going to start off the first part of this week though, talking about x and y intercepts. Getting into the first example, it says graph 3x minus y minus 2 equals 0. Now the key thing is to get the equations in standard form. This one is basically in standard form, but we do have two like terms to simplify it. We'll add 2, which gives us 3x minus y equal 2. Now keep in mind, we're trying to graph using the x and y intercepts. And basically what an intercept is if we have a graph, we know that this is the y-axis and this is the x-axis. The intercepts are where the graph crosses each axis, all right? So in order to find the x and y intercepts, we replace one with 0 in order to find the other. All right, so if we want to find the x-intercept, we replace y with 0. So the x-intercept will equal 3x minus 0 equals 2. 3x equals 2. All right, so we always divide the number that has the variable. So we divide by 3. X-intercept equals 2/3. All right. So in order to graph 2/3 on the x-axis, we know that if this is 0, this is 1, 2/3 will be somewhere up in here. All right. So that's our first point. Now we find the y-axis. So we want to replace 0 with x minus y equals 2. All right, that cancels. Negative y means negative 1y. All right, so we're basically dividing by negative 1. Y-intercept equals negative 2. So we go on the y-axis to negative 2, and then we draw our line through it. That's graphing using the x and y intercepts. All right, so next we're going to be dealing with graphing using the slope and y-intercept. But first we need to know what the slope is. We know that the slope is denoted by m. And the formula for slope is y sub 2 over y sub 1 equal x sub 2 minus x sub 1. All right, which is also rise over run. Okay, so that's the formula for slope. Now, if we had something like this, these ordered pair, and they ask us to find the slope of these two, we know that the first ordered pair are known as x sub 1 and y sub 1. The second ordered pair are known as x sub 2 and y sub 2. All right, so we're basically plugging in y sub 2 is 7 minus 3 over 6 minus 4. 7 minus 3 is 4. 6 minus 4 is 2. All right, so your slope would be 2 in this case. So the next example says graph using the y-intercept and slope. So what we have here is an equation in slope-intercept form. Y equals 3/4 x minus 2. So basically when we look at one of these, slope-intercept form, we know that M is known as the slope. B is known as the y-intercept, all right? The y-intercept being where the graph crosses the y-axis, right? And the slope meaning the steepness or the slant of the line. So we graph. All right, we have the first thing we want to do is graph the y-intercept. Now, if we look at this, we see that if we were to cover the slope up, the y-intercept would be y equals -2. So we would go to -2 on the y-axis, plot our point. Now, the slope is 3/4, all right? So 3 is the rise, 4 is the run. Both are positive. So we're going to rise from this point 3 units. 1, 2, 3. And we're going to run to the right 4. 1, 2, 3, 4. Then we plot. From there, we draw our line. All right, and we see that it's a positive slope because from left to right it's rising. All right, so next we're going to talk about the types of slopes. All right, so if we had x and y axis, now we're always working from left to right. So left to right, if the graph is going upward, then this would be positive slope. All right, a negative slope if we were working from left to right would be downward. A zero slope would be horizontal. And then we have what we call an undefined slope. An undefined slope is basically vertical, all right? An undefined slope is vertical. So the next one says, next example says, find the zero of each function. Then graph. So basically what we do is, say if we had the function f of x equal 5x plus 4. All right, so the way that we find a zero of a function is by, first of all, we replace f of x with 0, setting the entire function equal to 0. So we have 0 equals 5x plus 4, and then we would solve, all right? Subtract 4, so negative 4 equals 5x. We would divide 5 on both sides, right? So the zero of this function would be negative 4/5. So an ordered pair of this function would be negative 4/5 and 0. All right, another ordered pair of this function would be right, we have f of x equal f of 5 times 0 plus 4, which will give us f of x equal 4. So the other ordered pair would be 0, 4. All right, so x of 1 and y of 1, x of 2 and x of 2.